So now I will talk about the remaining difficult examples of the redox reactions in simple chemical cell. That means chapter 31. They are difficult because it will be a bit different from the easy examples that you have done before. For example, example 5. You will see that there are KBr and Br2 in the same half cell. As we know, potassium is a very weak oxidizing agent, so we can ignore it. So that means we will consider bromide and bromine. Bromide is a reducing agent, while bromine is oxidizing agent. So whether in the left half cell, whether reducing agent bromide will lose its electron, give out electron, or bromine will gain electron to become bromide, it's unknown yet. Okay, we still need to find it out. And on the right hand side, for the right half cell, hydrogen can lose its electron to become a hydrogen ion. That means it can be reducing agent. But when it comes to dilute hydrochloric acid, there is hydrogen ion. Hydrogen ion can gain electron to become hydrogen gas. That means it can be oxidizing agent. Same on the right hand side, there are oxidizing agent and reducing agent. So which one will be dominant? Which reducing agent will be dominant and lose electron, and which oxidizing agent will be stronger and take control and will be the dominant oxidizing agent and gain electron? Then we have to check. Remember, how do we compare the relative strength of oxidizing agent and reducing agent? Yes, the answer is we check ECS. So let's tidy the information we have first. For reducing agent, we have hydrogen and bromide. Okay, and for oxidizing agent, we have bromine and hydrogen ion. Actually, you just need to check either one of them. If you look at reducing agent, then you just need to check the reducing agent in ECS. If you are looking at oxidizing agent, then you just need to check the oxidizing agent in ECS. Okay, but now I'm explaining it, so I will check both of them. Okay, ECS. So we will go to the front page. So it's here. When we look at the non-metal parts, these are oxidizing agent and these are reducing agent, right? When we look at oxidizing agent, the lower one will be stronger. For reducing agent, the upper one will be stronger. And for reducing agent, hydrogen gas and bromide. So you can see that which one is stronger. Hydrogen gas is stronger, right? And when we look at oxidizing agent, really you do not need to check both. You just need to check one of them. Okay, because I am doing it as example, so I check both. And when it comes to oxidizing agent, bromine is stronger. Okay, now we go back to the question. Example 5 here. And for reducing agent, the higher one is stronger, right? So hydrogen gas is stronger. For oxidizing agent, the lower one is stronger. So bromine is stronger. So let's check oxidizing agent. Okay, oxidizing agent. Which one will take place? Which one will take control and will be dominant? Check here. Bromine is a stronger oxidizing agent, right? So this one will be dominant and this one will not discharge. And when it comes to reducing agent, hydrogen gas will be dominant and bromide is a weaker reducing agent, so it will not discharge. So now we can do the table. Now we can complete the table. Sorry for not showing A or B here, but I will electrode A means the left half cell. Okay, the electrode B means the right half cell. For at electrode A, that means the left half cell. As we said that by comparing the two oxidizing agents, hydrogen ion and bromine. Bromine is stronger, so bromine will discharge, and and we know that it will change to bromide. Okay, so I think you can do the rest of them. And for the right hand side, hydrogen gas will be dominant, and it will take control. It will take the role of reducing agent. Like on the left hand side, bromine will take the role of oxidizing agent. So I think you can deduce the observation and direction of electron flow. I can tell you earlier, at electrode B, hydrogen gas will change to hydrogen ion. So actually there's not much observable change, because hydrogen ion is also colorless, so we cannot see anything happening, but actually the hydrogen gas is turning to hydrogen ion. It's not obvious, but you can say the gas dissolve, but it's not that obvious because we cannot compare the amount of gas being bubbled into the solution. Okay, so that's all for example 5, and for the rest of them you can do it. And another difficult example is here, question 2. One type of breathalyzer, blah 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 blah, and consists is actually a chemical cell, and the breath of a driver is allowed to get into contact with the electrode, and if the driver has drunk, then it will have some ethanol in his breath, and the ethanol will conduct half reaction and turn to ethanoic acid, so that electric current will be produced. So it's already given to you, ethanol will turn to ethanoic acid. So can you complete the half ionic equation by adding, do you still remember the 3 steps? Adding water to balance number of oxygen, and the second step add hydrogen ion, and the last step add electron. So just follow these 3 steps to complete this half reaction. Then you can answer question A, B, C. Okay, explain whether it's oxidation or reduction. If you forget, then oil rig can help you. So oil rig. So stupid. So stupid. Oil rig can help you. Okay, you check the half equation. You check the completed half equation that you have done, and then you check it's losing electron or gaining electron, then you will know it's oxidation or reduction. And for part B, it's anode or cathode, then racket anodes can help you to define whether it's cathode or anode. Okay, and the last one, why this type of breathalyzer can estimate the amount of ethanol in the breath of the driver. As I said, if the driver drink a lot, then you will find a lot of ethanol in his breath. Then a lot of ethanol will turn to ethanoic acid to generate push a lot of electron to flow and to generate high electric currents. That's why it can be used to estimate the amount of ethanol. Okay, and example 6. Okay, you can take a pause to read the question, but it's also easy because although the chemicals cannot be found in the common oxidizing agent and common reducing agent table, but you can read question carefully. As I said before, if you don't know, then also other Hong Kong Form 6, Form 5 students would either know. So read the question carefully, they would give you some hints. Zinc will turn to, that's iron. Oxygen will turn to hydroxide ion. So you can try to complete the half equation by yourself. And please pay attention that the electrolyte is potassium iodide. That means it will be an alkaline condition. Okay, so for the equations that you have done, you have to turn it to alkaline condition. For example, first one, zinc. For zinc will turn to zinc, this iron, and according to what we have learned, we the 3 steps, remember, add water, and then add hydrogen ion, and at last add electron. But it's alkaline condition, so please turn it to alkaline condition. The hydrogen ions should not appear, so we add 4 hydroxide here and add 4 hydroxide on the opposite side to make sure it's equal. Okay, so now it's done, and then it become if you know how to do H, then you can skip it already. Okay, 4 water. Okay, and then to simplify it, so we deduct 2 water from both sides, so it's done. And then for another side, oxygen gas will turn to hydroxide to balance the number of oxygen first. Because there are 2 oxygen, so 2 hydroxide will be formed. And can you do the rest of them like the zinc, the half reaction taking place on zinc? Remember, do you know how to do? Adding hydrogen ion and then add electron and turn it to alkaline condition. Turn it to alkaline condition. Okay, do it by yourself. I'm not going to do it. So write the balance equation occurring at zinc and graphite. I have done one for you already. Another one, turn it to alkaline condition. Okay. And write the overall equation. Identify its anode or cathode. Okay, so for the rest of them, you can do it. And the last difficult example, the last one. Read the question carefully. Okay, the cell will operate as under 300 degrees Celsius. And this one is easier, I think, because you can find the oxidizing agent and reducing agent from the chemical equation here. Okay, so sodium, the gray part is connected to electrode A. Okay, and nickel 2 chloride, the green part is connected to electrode B. So what's happening at electrode A and B respectively? Can you see that sodium? So here, sodium. What is sodium changed to? What does sodium change to? From the chemical equation, you can see that sodium will change to sodium chloride, right? So to balance it, adding chloride ion, and the last step, add electron. Okay, I think you can do it. Add electron, the last step. Okay, wrong. Yes, wrong. It contradicts. Become 2 positive on the left, so it's wrong. And then it should be only 1 electron. Okay, and then for at electrode B, it's nickel 2 plus, and then it will turn to nickel. So I think you can do it like electrode 8 that I have done, okay? And answer when you know the two half reactions taking place as the two electrode respectively, then I think you can answer all the questions from A and D, okay? Try to do it by yourself. That's all. So in this assignment you have in this task you have to complete example 5 and question 2, example 6 and example